All information and content in this video demonstration is strictly for educational and self-study purposes. Never attempt to tamper with any computer or network you have not been given explicit authorization to do so. Use a personal lab. Have fun.
The first step will be to find a stored cross-site scripting vulnerability in the environment. A user will browse the area of the web page with the stored XSS. This will make the BEEF connection. We will send the pretty theft instruction for the user browser to display. If the attack is convincing enough, a user will disclose their password as a result. Cross-site scripting vulnerabilities can be found quite often in organization environments. Browser security can be a blind spot for security controls. Because the chain only uses web and browser technology, there will be no logging in Active Directory like we see with brute force and spraying. There are some particulars in the attack is not targeted. It is possible to get some, many, or no users falling victim to the attack.
Let's get started.
Our threat actor stumbles upon a simple chat system. The threat actor puts in a string of text to observe the output and result. Some HTML and some JavaScript you can see here.
A simple test which should display an alert box with the text "Oh hi Mark." That should do it.
The alert box is an indicator that an XSS vulnerability exists. The threat actor confirms the XSS is stored by looking at the page code. We can see the comment is stored and the XSS is successful. Once the threat actor has found the proper place for the XSS, they will start up BEEF. Returning to the web page, our threat actor inputs another string. The difference is this time, instead of an alert box, JavaScript will be executed. The JavaScript will connect the victim's browser to the threat actor's BEEF server. The hook is set.
I am Owen and this is a website I use at work to check comments. The authentication is simple and not integrated to anything. It can be tough having to use more than one password sometimes. I've logged into this web application. It starts up here in my profile. I should check if there are any new comments to read. I don't see anything new. Just these strange blanks.
Now if we peek into the threat actor's BEEF console, we can see one browser is online, up there. The threat actor focuses on the new browser and moves to the commands. Commands, then social engineering, and finally, pretty theft. Because the threat actor is targeting Active Directory credentials, the dialog type box is changed from Facebook to Windows. The instruction is sent.
What is this? I bet the network proxy is timing out again. This login is for the domain. My password is hard to remember. We use long and complex passwords for security reasons. Almost done. I'll check the remember box so it will stop popping up. Okay, that should do the trick. I'll go ahead and check my other apps.
There in the BEEF console is command 1, this would be the instruction we sent. Let's check the result. Oh no. Unfortunately, a user has fallen for the trick and disclosed their Active Directory login information. The threat actor now has a credential that can be used for initial access to the directory services. Here are some suggestions for preventing the start of the chain. Consistently discover and patch vulnerabilities in the environment. Encourage secure coding practices where possible. A web application firewall can block the cross-site scripting execution in between the browser and the vulnerable web server. At the browser level there it would require tight control over script execution, such as JavaScript. Looking at the MITRE attack matrix. The technique for capturing input through the GUI is listed, ID number T1056.002. The mitigation is identification MO17. This is user training. In the MITRE defend matrix, the countermeasure for a stolen password is credential rotation. This is ID number D3, CRO.
The end.